Okay, the last video clip dealt with the structure of the Earth. We learned that we can divide the Earth into 3 layers if we're discussing the composition of the Earth. And we learned that we can divide the Earth's layers into 5 layers if we're discussing the physical properties of how those layers act. Next, we're going to use our understanding of Earth's structure to explain an observation that we can make about the Earth. Check out this beautiful image of the Earth from nasa.gov. Notice that the ocean crust is at a lower elevation than the continental crust. It's a pretty obvious observation, really, but you've probably never thought of that before. What would happen if both the oceanic crust and the continental crust were at exactly the same elevation? Well, the Earth's surface would be completely covered with water, and life as we know it would be much different. So thank goodness the ocean crust is lower than the continental crust. But why? Why is the oceanic crust at a lower elevation than the continental crust? We covered everything we need to know to answer that question back when we covered the composition of the Earth's crust. There are 2 reasons why the oceanic crust is at a lower elevation than the continental crust. The first and less important reason is the thickness of the 2 types of crust. You'll remember, and you can see from this diagram, that the oceanic crust is much thinner than the continental crust. The most important reason, however, is that the oceanic crust is made out of basalt, which is more dense than the continental crust, which was made out of granite. That's it. So why is the oceanic crust at a lower elevation than the continental crust? The oceanic crust, which is made out of basalt, is more dense than the continental crust, which is made out of granite. I encourage you to get that in your notes. Next, let's check out the density of the mantle and note its location below the crust. With that in mind, could you predict the density of the core? You guessed it, even greater. This is an important point. Earth materials are arranged by density. We've run into this idea before. In week number 1, we noted that the atmosphere is less dense than the water, which is less dense than the solid Earth. Thus, the atmosphere is above the liquid water, and the liquid water, the oceans and lakes, are above the solid Earth. Earth materials are arranged by density. Even our place on Earth is governed by density. We don't float up into the sky because we are more dense than the atmosphere. We don't sink down into the Earth because we are less dense than the Earth. Our density is approximately that of water, so we bob around at that level. Another concept that relates to the position of Earth materials is isostasy, the gravitational equilibrium between the Earth's lithosphere and asthenosphere. Basically, what's happening here is that the lithosphere sinks downward, when new material is added onto it through the deposit of sediments or volcanism or whatnot. And then when that material is removed due to erosion, the lithosphere will rise back up. So there's a sinking down when weight is added and a rising up when weight is removed. We'll revisit this term later in the course.